Okay, so in this video we're going to cover WaterCAD, the second part. We introduced WaterCAD into the class at the end of the semester, and this is going to help you be able to finish the project for the final. And so let's get started. So we go ahead and share the screen. I've brought up WaterCAD already, and it comes up with this dialog box here, and quick start lessons if you want to watch additional information on WaterCAD, or open an existing one or create a new one. So we're going to go create a new one. So I'll get that started here. It opens up our drawing window right here, and we've got our other windows here to the side that we can close if we want. But I'm going to go ahead and click on yes for tracking changes. And once we get going, then my goal for this one is I'm going to run through really quickly what we talked about briefly before, and then we're going to work on the project that we did in class using the numerical methods to solve this little pipe network, and just kind of show you how we would set that up and go ahead and solve that. So first off, when we get going, there's two things that we want to do. We want to change this from a scaled drawing over to a schematic. Schematic means that we're not necessarily going to put the lines in at scale. We're not pulling in information from AutoCAD or for some other graphics package. We just want to get this going as a simple drawing, and then we'll input all the information. So I talked about this in class, but I didn't show you how. So I come over to Tools and then More. So the Tools tab, click on More, brings up the pop-up window, and I'm going to select on Options. So what this does is this brings up all the defaults. Well, not all of them, but some of the key defaults that we're going to start with here in WaterCAD. Several different options across here: hydraulic model, the drawing, and the units. And right now I'm in US customary, and this shows you all the basic units that WaterCAD has inside. And I'm going to leave the defaults there. Labeling, you can change the default labels as well, where you can put in different values for the pipes and for the lengths. If you don't like P- for the pipes, you can change those. But once again, I'll leave those to the default. Come back to the drawing, and right here, the drawing mode right now is in scaled. That is the default. We're going to change that over to schematic, and everything else will leave as default, and go ahead and click on OK. All right, so now we're ready to go as far as the drawing is concerned. Now I'm going to come to home, and I'm going to click on Options, and underneath Options has the base calculation options, because remember, we want to do this. I'm going to double click, or you could right mouse click and select properties. Let me show you that really quickly. Right mouse click base calculations and bring up properties. And we want to change the friction method, because the Darcy-Weisbach, in my opinion, is the better of the two. So we're going to go over to Darcy-Weisbach, and it's all good to go. Now we're ready to close the two windows out. We're ready to put the model in. So I'm going to go to Layout, and I'm going to change from our initial here of a 2 tanks. I'm going to put 1 reservoir and 1 tank in, just so you can see how that works together. So I'll start off by putting in a reservoir. So I'm just going to click on the screen, put reservoir in there, and then I'm going to select pipe. And pipe allows me to put in junctions at the same time I do pipe. I could come in and select junction and come over here and just put that in as well, right there for like the first junction, and then put all my junction in. And that's fine as well. But so my pipe, go ahead and click on pipe there, and I'm going to connect this reservoir to this junction. And then I'm going to go ahead and click on, go around my pipe network and put my different junctions in. Okay. And if I want to get rid of, if I want to break the pipe, if you will, I'm going to hit the escape key, and now I can come back in and add that back in wherever I need to go. And I'll put one more in over here. Okay. And I realize that this junction 5, that needs to be a tank, not a node. So I can come up here and let's see. Okay, so I'm going to come in and select tank, and I'm going to come over here and put this on that node and click on tank. I could have, once again, I could have put it there and then just connected the pipe, but if I make a mistake and it's like, okay, let's go ahead and put that tank in, It'll ask me, would you like to morph junction 5 into the tank type? And I'll put yes. It switches that to a tank. And the pump, I could have added the pump as well and connected the pipe to it, or I can come in here and say, all right, let's go ahead and split the pipe to put in a pump. Okay. Now the disadvantage of doing that is it does kind of change your numbering a little bit, but that's not very, critical as well. And I can come in and renumber these if I need to. I'm going to grab these labels and just kind of move them just by highlighting, grabbing the red point there. Reservoir 1, move that over here, just make it a little bit easier to see what I have going on. All right. Now I can bring up each one of these and edit their properties simply by using the select button and double click and bring up the properties tab for the reservoir. This particular reservoir, if I come back to my drawing, had an elevation of 320. So I'm going to come down here to the elevation right here and put in 320. There we go. And then just go ahead and close that out. And so that's in there now. And I could go around to each one of my pipes and put in lengths for them as well. Move this back up here, like that, pipe 1, 2 there. All right. So for example, I could bring up a junction. I could relabel that junction if I wanted to. Down here, I could change this label, but I'm going to keep that current one. There's the demands that go into junctions. We'll come back to demands in just a little bit, but I can also put in an elevation. And according to the handout, the elevation for this is 320 for junction number 1. So now that I have that in there, enter that. Okay. So I can go around and do all that, but there is an easier way of doing this. And the easier way is come back to the Home tab and go to the Flex Tables. So inside the Flex Tables, I'm going to go ahead and bring up the pipe Flex Table. So here's all my different junctions right in here. And once again, the kind of grayed out, or in this case, a little bit of an orange color, it has, those are values that I can't change inside my Flex Tables. But as far as the diameters go, I could change the diameters, and I could do those individually. Okay, just come in here and change those individually, or I believe that I can highlight a bunch. I guess not, you have to do those individually. So you can put in the diameters. Now, if you decide that you don't want to put it in inches, you can come up here and right click on the header, and you can actually edit the column label. So you can come in here and change that. If you don't want to call it diameter, you can call it something else. You can actually come in here in units and formatting, and you can change the unit type. Right now it's in inches. I could go to feet if I wanted to. Well, we do pipe sizes in inches, so I'm going to keep that inches, but I can also change the precision. If I want to have more precision on each one of these, I can change the number format as well. So we'll go ahead and keep that at 6 for right now. The material, ductile iron, I can, if this is PVC or something else, I could go ahead and click on that. And so once again, in a typical notation, 3 dots means it's going to bring up a new menu. So I come over here to the material databases. I could add a new material if I wanted to, or I can look at the material database they already have. You can see they have a bunch already here: concrete, corrugated metal pipe, PVC. So I can select on whatever I think I have. And I could also, I guess it jumped a little quick here. Let's bring that up again. So if I cast iron pipe, for example, and I can look over here and say, all right, is the roughness height right here what I would expect it to be? If we were using Hayes and Williams, this is where we would put it in, or if we're using Manning's, we would put that value in there as well. But I'm going to stick with the defaults for now. Okay. Now, if you have a check valve inside your system, you can actually, let me come back to the system here. I could put a check valve, and if I go to layout, and I can find all the different valves that they have over here, and within these valves, I could find the check valve, and I could insert that check valve inside my pipeline, and I could give that valve different properties that it needs to have. So let me just grab a valve here and just stick a valve down here, and then come back to my select tool and double click on that valve. And you can see there's a lot of different properties that I can add to that check valve, or this particular valve. Flow control valve is a lot of these different things. But since that's not part of my system, I'm just going to go ahead and delete that. Okay. But going back to the flex tables, you'll notice for the pipe flex table, it has a little comment right here. It has a check valve. All right. Now, typically we put in check valves when we put in a pump to prevent the flow from going backwards through the pump, because that's not very good on pumps. And so if you have a check valve, rather than adding the check valve into the system, you just kind of go ahead and check on that, and it would add that check valve to your system. All right, because I've done a schematic, it says has user-defined length. So I'm going to go back to my table over here where I have all my different lengths right there. And I'm going to enter those lengths into my flex table. Okay. Noting that pipe number 1 has changed. And I guess I should change my diameters here. So let's go back and do that first. So pipe number 1 was a 12-inch pipe. Okay. And pipe 2, whoops, I got to make sure I get my things here. Pipe 1 and 2 are down here again. So these are 12-inch pipes. I split that pipe to put a pump into it because WaterCAD has to have a node for a pump. Pipe number 2 now is an 8-inch pipe. Pipe number 3 is an 8-inch pipe. Pipe number 4 is a 6-inch pipe. Pipe number 5 is an 8-inch pipe. Okay. Pipe number 6 is an 8-inch pipe. And pipe number 7 is a 10-inch pipe. Okay. And make sure I put my check valve in the right one, because my check valve now goes in between the reservoir. So pipe 1 goes from the reservoir to the pump. Pipe 2 goes from the pump to the junction. So I'm going to put it in that pipe right there. And, you know, I can change these to PVC or ductile iron. I'm just going to leave those the same for now. And now let's come over to the length. So coming back to the lengths, I'm going to assume that my pump is halfway between, and so that was 1,000 feet for pipe 1 in our original model. So I'm going to split those in half, and then come up here 800, 700. So it's like a spreadsheet when I enter this information. Just make sure you get the right values into the right pipe. Okay, so now I have the right diameters, the right pipe type, I have a check valve, and I have the right length for my all my different pipes there. So I can close that out. Notice that it's put a flow direction for my pump, saying the flow is expected to go this way because it has a check valve. The check valve will stop it if it goes the other direction. Okay, now if I wanted to come back here and click on this pipe, by the way, and this is the pipe that has the check valve in it. Okay, we can see that it's a 12-inch ductile iron, and it has a check valve. And right here, it says specify local minor loss. And so if I wanted to put the minor loss in there for our check valve, I could. Now in our simulation, we didn't have a minor loss, but I'm going to go ahead and put one here. 0.1 is the minor loss coefficient for that check valve. Okay, additional information here if I wanted to add like water quality and so forth. Once again, a lot of different things we can do with this program, but we're just going to keep it pretty basic. So I've got the check valve in, and I've identified the minor loss coefficient associated with that check valve. All right. Now let's make sure we get all the junctions in. So we could click on each junction individually, or once again, come back to the flex tables and bring up the junction. Okay. And I've got my 4 junctions here. I've got an elevation associated with each one of those. I've already got one in, so I'll go ahead and put the rest of those in. 330, 310. And the last one is 300. Okay. So now that I've got, come on, go ahead and enter that in. There we go. And now there is a demand associated with each one of these. All right. So I could come back up to my alternatives and enter the demands up there, which we'll see here in a minute, or I can put those directly in here. So I'm just going to go ahead and click on the demand right here. And right now it says the demand based in gallons per minute. Well, on our homework problem, those were in cubic feet per second. So I'm going to go ahead and change this over to cubic feet per second right there. And now I can go ahead and put the value in there. At junction 1, we had 2. Why that's not letting me put that in there. Let's take, oh, here we go. So the pattern needs to be fixed. There we go. So now that it's fixed, now I can come in and put the 2 in there. Okay. So the fixed allows it, if we're doing a transient analysis where we have different times, that's where we put it there. But right now we're just going to go ahead. So fixed, and in junction 2, we have 4 CFS. Okay. And then for number 3, let's again fix the pattern. And this one has a value of 1 CFS. And then the last one then, fixed pattern, the value of 3. Whoops. Numbers lock key is turned off. All right, there we go. Okay, now we can also put them in zones. If you're doing a really big system, it's most likely operating in zones, but we're not. This is relatively small. So now we have the elevations and we have the demands in there for our base flow, and we are done with that. Okay, so what do we have left? Well, we haven't defined the pump and we haven't defined the tank. So we've got our pipes and our nodes done. So I want to come over here and define the pump. Now there's 2 ways that I can define the pump. You'll notice that here on the home button, there is a pump definitions up here. This is where you can put in multiple pumps. You can try different pump types to see how they work and so forth. Or you can double click and bring up the properties tab. So let me show you. Pump definitions is going to bring up this screen right here. And I'm not going to do anything with that just yet. Notice it says pump definitions. All right, now if I come back here and double click on my pump, it's going to bring up the pump properties. And down here towards the bottom of the screen, it's going to say pump definition. Right now it says none. Pull a little click down menu. There's none that I've entered in. So it says edit pump definitions, and it's going to bring up that same box. So it's kind of like Excel. There's multiple ways of doing the same thing. So I'm going to go ahead and add the pump here. So click on the new. And I'm going to just call this the basic pump. Okay, you can call it whatever you want. You can leave it as the default. Right now, we're going to use the standard 3-point method to define our pump. This is what we did in class. So the shutoff head is 0 gallons per minute. The shutoff flow is 0 gallons per minute. The head, if we go back to our little drawing here, is 116. So 116 in here. Okay, the design point where we kind of expect it to run is going to be at 110 at a flow of 4 CFS. Now, once again, we would generally enter this in gallons per minute in the real life because our pumps are measured in gallons per minute. But numerically in Excel, we did it in cubic feet per second because that's what our equations were set up for. But I'm going to go ahead and change this over then to cubic feet per second. Yeah, and that's, I'll do a one decimal precision. Go ahead and click on OK. All right, so now my design is 4 and my max operating is 8. All right, there we go. And I got to put in the operating head over here. At 8 CFS, I have 95. Okay. All righty. Now you'll see that it puts a pump curve in here. It's not exactly perfect, but it's the best fit match. That's the blue one. Okay. The red one, this is efficiency. So I need to have some way of defining the efficiency. And in this particular problem, we didn't give you the efficiency, but we could define a couple of like the best efficient point, let's say, is at 4 CFS and has efficiency of 85. Then the red line then represents the efficiency of our pump as a single line. Rather than contour lines, it does it as a single line. Once again, that would be based on the flow rate. So if I was running at a flow of 10 CFS right here, which would be a head of approximately 85 or so, I would have an efficiency of about 72% or so. So you base the efficiency based on the flow. It would be best to put in more multiple efficiency points if we wanted to get a really good accuracy of what's going on. But for now, you don't even need to have the efficiency in there. That's when you're doing a cost analysis on the maintenance or the operation cost of the pump. So just make sure that you get the head curve in here. That's the blue line. Okay. And we can go ahead and close that out. I did call this as a basic pump. I would note that we can add in, if it's a variable speed drive, you can add this here, and then you can come in and put in different speeds and efficiencies to better understand how your pump is operating. But net positive suction head can also be added in here. All right. And we'll just keep it basic and do the basic pump. So I'm gonna go ahead and close this out. So now when I'm doing this pump, once again, if I did pump definitions, bring it up, there's my basic pump right there. Okay, I can have more than one pump. I can add all sorts of pumps in there. So now when I go ahead and bring up my pump here, I'm gonna go ahead and put it at an elevation as well, physical elevation. We'll call it the same reservoir elevation, or the same elevation as the reservoir. But we need to add in the pump operation. So the pump definition then right now is none. We go ahead and select this and put in the basic pump. Okay, so it selects the basic pump, tells me some information about it. And now our pump is good and ready to go. Okay, so the only thing left that we have is our tank over here. So I'm going to go ahead and double click on that tank. Okay. And the tank then operates a little bit different than the reservoir because tanks, you can put controls on them so they move up and down. Tanks may be elevated off the ground. So you could say, what is the base elevation? Then what is the minimum elevation of the tank? So in our particular problem, we have an initial elevation of 420. Okay, that's where we're going to operate this at steady state. I'm just going to put a few values in here, 410. I'm going to say the base elevation is 405. So we always keep like 5 feet in our tank. And the maximum then is 425. These values in a steady state analysis do not matter, but you're going to want to put some in there just to make sure that your initial elevation is bracketed between those. Okay. And if you have a base elevation, you could also put this down here as the physical elevation as well, 405. All right. Kind of tells you where it's connected. And now our tank is good and ready to go. All right. So as far as a simple analysis, we've got a pump hooked up to the reservoir that's going to supply the flow into our system. We've identified all the demands of the nodes and how the tank on the other side works. So now we just need to go ahead and compute. So we can just go ahead and compute the basic simulation. Okay. And everything here looks good. There's no error messages down here in this little box. So I'm going to go ahead and close that out. I did get an error down here, base, scenario base, negative pressures in system at 1 or more time steps. That's interesting. Let's take a look at the pressures. See what we got going on here. See what I messed up on. Okay, so to see the results, I want to come back to my flex tables, and I can go ahead and bring up the pipe flex table. And so I can see my different flow rates. Negative flow rate just means that it's going in a different direction than what I originally thought. I have the velocities. I want to try and keep my velocities hopefully down around 5. You can go as high as 8, maybe 10, 15 in rare cases, but usually that's too high of a velocity that you want to design for. So 5 to 8 is kind of where we typically try to have the maximum velocity. And this one seems to be okay there. We got our check valve, everything else there seems to be fine. So once again, we can get our velocities in our pipes and our flow rates and the directions in each one of those. Now it did put the directions on the drawing itself. Pen up here, there we go. So you can see the directions that it's going. And of course, pipe 3, where I drag the pipe from junction 2 to junction 3, is going to be negative because it says the flow is going in the opposite direction. Let's bring up the junction table. And I'm not sure why we got a negative pressure. That just must have been just a little numerical glitch. Close that out. All right, because right now in steady state analysis, given the demands we've put in there and that pump curve, we have pressures of 36, 27, 40, and 40 at those different junctions. Okay. We could look at the hydraulic grade line. We can actually add different things to this. If we do add a column or remove a column, water quality, demand. Demand's already up there, so we don't need that. Fire flows. So things are good right there. So maybe if we go back into the pipe 1, we can take a look at that. So this here is pretty good. Oh, I should note that if we come back up to pipe flows, come back up to pipes here. Now this should be fairly close to what you did in the numerical simulation, but not exactly. And the reason why it's not going to be exact, because remember in class when we did the Excel method, we fixed the friction factor. And this particular program actually calculates the friction factor based on the flow rate. So if you looked at it, these flows should be somewhat close, but not exactly on. All right. Okay, let's see. Let's take a look at what columns we have going on here. You can look at the head loss across each pipeline, the head loss due to friction, which should be the same unless there's like a valve in one of them. You can look at the pressure loss, so forth. Of course, right here we do have the head loss gradient. Tells us how much each one of those pipes is, how fast it's taking energy out of the system. So that right there gives you then a pretty good idea of how to run the program. Now, I would note that we can do scenarios inside of WaterCAD, all sorts of scenarios, what if scenarios. We can do timed controls, but I'd like to show you how to do a what if scenario type of thing, because for your project, you're going to have to enter a couple extra flows. So I'm going to come back up here to my alternatives, and these are the different things we can change, but I want to change the demand. So here we have the base demand. I want to use the same method, the friction factor we're going to use for the base demand. We could start another one and actually put in, in fact, that might be kind of interesting. So I'm going to come back up here to the demand and add one. Well, I wanted this to be underneath that one. Oh, I guess it is. Okay, that's what I'm trying to show here. Demand alternative 1, and I can rename this. Well, demand associated. Okay, maybe I'm getting outside a little bit than what I'm normally used to here. I'm going to go ahead and delete this one here. And let's just do this. Base demand, I'm going to add one underneath the base demand. So you see how it kind of went underneath base demand rather than the regular demand. And now I can come into that one and I can change my demand bases over here. Okay. So where I can come in here and I could say, well, I want to bump that up to say 3. And well, 4 for that one. So so this one was 3, bumped up to 3, and I say I wanted to take this down to 2. And so I can actually change the demands for each one of those. Now there is a method in here that you could put like multiplication factors, peaking factors and things like that, but we don't want to get that fancy. But I do want to change the demands so you can kind of get an idea of what happens when you when you change a flow rate in a system, or how much the water needs to happen. So you could look at the max day, you could look at the peak flow, you could look at the peak flow and fires, you can look at what if we had other demands on our system, and run those. So now I've got these two separate demands. I don't have to change any of my pipe types. But now when I come over here to compute, I can okay. Let's see. I need to go to options and did my calculations there. Oh, scenarios. Okay, that's what I want. I want to look at my different scenarios. And now I have my base flow. I want to add a new one, and it's going to be a child scenario. So I'm going to pull off of this. And this is where I'm going to do the new demands, whatever I want to call that. Okay. And that new demands then. And I want to come in here. So these are the things I want to change. So under my scenario new demands, the demand, rather than the base demand, I'm going to use the demand alternative number 1. All right. And now I have my base, and then I have new demands. And so now when I have that one clicked, whoops, right here, I want to check that one there. So use the little check mark. Then I can go ahead and run this one. Okay. So now when I go ahead and bring this up, close that out, bring up my flex tables. Whoops. Bring up my little pull down menu here and look at the pipes. All right, now we have considerably different flows in the pipes than we had before, and considerably different pressures in the pipe. Okay, by changing the demand. So once again, we can come into alternatives, and I can add either underneath the demand or under the alternate demand the different scenario. I'm just thinking here under the physical alternative, if I bring that up, so I was just thinking about maybe changing over to the Colebrook-White, the Hazen-Williams equation, and comparing those two. But forget how to do that easily. So I thought I should be able to just go in here and, well, let's see, maybe I can edit this. New, duplicate, open. Let's look at the properties here. Physical alternative. All right, well, maybe I'm getting too deep for now, and I have to go back and review myself. But now you know how to put in a different base demand, and you can run that. And the advantage of this is that it's going to allow you to have multiple scenarios within your file, so you're not going to have to keep track of multiple files. When I come up here and say file save, it's going to save both of those scenarios. So this is the Excel problem. Save both of those scenarios, because you're going to have to send me your file in, and you're going to have a couple different scenarios, and I want to be able to open it up and take a look at all those. Okay. But with that, just as a quick recap, showed you how to start the program, showed you how to add all the different components with the junctions, the tank, the reservoir, a pump. Make sure you know how to put in a check valve, and then the output of the answer. And from here, you can now go into kind of design. You can set parameters and say, all right, what if the flow or the pressure at one junction is low? Or in a particular pipe, it's kind of low. Now, the reason why they report pressures at junctions is because a pipe has multiple pressures. One end is a high pressure, the other end's a low pressure. So we don't look at pressures in pipe, we look at velocities in pipe and then pressures at junctions. If you have a junction that is low, then you can decide, well, do I want to add another pipe? Do I want to increase the diameter of the pipe because that'll reduce the friction loss? Do I want to change my pump out, increase a bigger pump? Do I want to add another reservoir in? Reduce the demands of that junction? In real life, I'm not sure what that entail. Maybe we put a flow restriction on there. But there's a lot of different ways to make sure that we have different scenarios or that we meet the design parameters that we're trying to meet for our design. All right, so with that, we'll wrap this up and hopefully that'll give you a good start on your project. So we'll stop sharing there and